Okay, I know that quizzes 7A and 7B contain a few questions we didn't talk explicitly about in the lectures, so let's look at those here. The first thing we want to do is talk about the negative of rational expressions. We did talk briefly about the negative of rational expressions, but let's take a look at this one more time. When there's a negative sign in front of a rational expression, what's important to remember is that that does not equal the negative of the numerator and the denominator. Because when we have a negative divided by a negative, that makes the whole thing positive. So this is not correct to write a negative sign in front of both the numerator and the denominator. There are two possibilities. The first is to say we have the negative of the numerator. The other possibility is to say we have the negative of the denominator. So here are two equivalent expressions. These are both equal to the negative of the entire expression. We can open the brackets. For the first one, that gives us negative x minus 2 all over x minus 7. Here's another equivalent expression. If we open the brackets here, we have x plus 2 over negative x plus 7. This is another equivalent expression. And in fact, for the last one, because I don't necessarily like that negative in front, we could write this as x plus 2 over 7 minus x. So you see there are many different ways we can write expressions that are all equal to our original expression. Why don't you pause your video and see if you can find 4 expressions equivalent to this one. So we know we can write the negative in the numerator. Here's one equivalent expression. We can open the brackets. Here's another equivalent expression. We can also take and rewrite the numerator. So we have x minus 3 over x plus 5. Alternatively, we could put the negative sign in the denominator. Giving us another equivalent expression. If we open the brackets, so there we have 5 expressions, all equivalent to our original expression. Now I noticed in my math lab that they talk about the lowest common denominator or the least common denominator. They're asking for the same thing I talked about when I talked about the lowest common multiple of the denominators. It's just a shorter way of saying LCM of the denominators. They've shortened it to lowest common denominator. So how do we find a lowest common denominator? First thing you have to do is factor the denominators. So I have x plus 2, x minus 2 times x plus 4 for the first expression. X plus 4 times x plus 2 For the second expression, the lowest common denominator or the least common multiple of the denominator, my first expression needs x minus 2. Second expression needs x plus 4, or sorry, first expression also needs x plus 4. Second expression needs x plus 4. We already have it. I also need x plus 2. Pause your video and find the LCD of the denominators, the lowest common denominator of question 2. The lowest common multiple of the denominators, or the LCD. My first expression needs x minus 1 and x minus 3. My second expression needs x minus 2. I already have x minus 1. There were also a couple questions that explicitly ask you to find equivalent expressions. We used equivalent expressions when we were adding and subtracting, but we didn't talk about them outside of addition and subtraction. Let's do that here. When we're creating an equivalent expression, the first thing you want to do is factor the denominators and then multiply the numerator and the denominator by the missing factors. So if we look at this example, if I factor my denominator, I can see I have this. Remember, we're looking for the missing factors. Well, what's missing? I don't have y. There's a 3, there's an x minus 5, but there's no y. So I need to multiply the numerator and the denominator by y. My equivalent expression then is 7y over 3y times x minus 5. There are 3 questions for you here. Why don't you pause your video and see if you can find an equivalent expression. There's nothing to factor in this first denominator. But if I factor this denominator, I can see that I have 7 times 11 times a to the power of 5 times b squared. Well, the 11 is already here, and the a squared is here, but not a to the power of 5. What's missing? Well, I'm certainly missing the factor of 7. I'm also missing a to the power of 3. When I multiply those, it's going to give me a to the power of 5. There's no b here either. The missing factors are 7, a cubed, b squared. When I multiply that by the numerator to create my equivalent expression, I have negative 28 a cubed b squared all over 77 a to the power of 5 b squared. I hope you noticed that all that was missing in the second expression is this factor of y. My equivalent expression is negative 4y over the denominator. I have to factor this denominator. I see that 3 is common. So I have 3 times x plus 4 times x plus 2. There's a 3, there's an x plus 4. We're missing that factor of x plus 2. When we multiply x plus 2 by x minus 1, we get x squared plus x minus 2 all over the denominator. I hope that helps you with quizzes 7A and 7B.